Place value is defined as the value of the digit depending on its place. The easiest place to start is, of course, with the decimal point. Every number has a decimal point. So if we start at the decimal point and we go up, we have ones, tens, hundreds. This is the first period. Then it goes to thousands, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, all the way to billions. The pattern continues. Ones, tens, hundreds, thousands, 10,000, 100,000, million, 10 million, 100 million, billions. The value of a digit depends on where it is on a number line. If we start at the decimal, we can also go to the right of it. We have 10, 100. If a number ends with that means it is on the right side of the decimal. If it has thousands, it is on the left side of the decimal. As we take a look at a place value chart, we said that a place value is defined as the value of a digit depending on where it is. So if we take a look at the digit 1 and we place it here, the digit 1 has a value of 1. But if I move the digit 1 to the left and I place it here, even though the digit is still the same, it now has a value of 10. Same digit, but it now has a different value because of where it is on the number line. Same thing if I move it 1 to the left. I place it here. Just by placing it under the hundreds, it now has a 100 value. This pattern continues the same way. If you keep moving it 1 to the left, it gives it a greater value. Now it has 1,000. This pattern continues as you move to the left of the decimal. When we went from 1 to tens, the value went 1 to 10, which is 10 times greater than 1. Same pattern happens when we moved from tens to hundreds. The value was 10 times greater. Same thing with hundreds to thousands. The value is 10 times greater. This pattern can continue all the way. Anytime you move 1 to the left, the value becomes 10 times greater. This same pattern happens everywhere. If I go from the hundreds 1 to the left, tens is 10 times greater. From tenths to 1 is 10 times greater. So anytime you move 1 to the left, you are getting 10 times bigger than where you started. But what if we go to the right? If we went from 100,000s to 10,000s, well, we're doing the opposite of what we did when we did 10 times greater. So the opposite of 10 times is to divide by 10. Or you could say multiply times 1/10. Either way, it is the same. When we move from 10,000 to the thousands, we can say we are dividing by 10 or multiplying by 1/10. All the way down, the pattern continues. Divide by 10 or multiply times 1/10. Dividing by 10 or multiplying by 1/10 will give you one place value to the right. So let's take a look at how this might come up as a question. Here's a good example. In which number is the value of the digit in the hundreds place 10 times as much as the value of the digit in the tens place? Before we even look at our answer choices, let's look at some important keywords here. It says the hundreds place, the tens place, 10 times. I'm going to make a little note here, times 10. It also says the digit, meaning that the digit is the same. What changes is the value. So now let's look at our answer choices. The way I suggest tackling any problem that has to do with place value is to first draw a place value chart. If we look at our answer choices and we start by placing it in our place value chart, we have 82,239. Remember, we are only looking at the hundreds and tens place value. And if you look at it, we have a 3 in the tens place value and a 2 in the hundreds. It's not the same digit, so they cannot be 10 times as much. So A is out. Let's look at B. 18,809. Again, only looking at the tens and hundreds place. We have a 0 and an 8. It cannot be 10 times as much because they're not the same digit. So B is out. Let's look at C. We have 46,155. We have a 5 in the tens and a 1 in the hundreds. Not the same digit, so it cannot be 10 times as much. C is out. D, 20,553. We have a 5 in the tens and a 5 in the hundreds. So if we look at this 5 has a value of 50. And this 5 has a value of 500. If you remember, when we moved to the left, it was 10 times. So let's work it out. We have 50 times 10, which gives us 500. Because it's the same number, D is our answer. Here's another common type of example. Let's take a look at it. It says the value of the box digit is blank the value of the circle digit. So if you look at both digits, it's 7. This 7 is 700, while this 7 has the value of 7,000. And it says the value of the boxed digit is blank the value of the circle digit. So when we look at it, we're not going from 700 to 7,000. We're going from 7,000 to 700. We're going to the right. And we already know when we go to the left, it's times 10. But when we go to the right, it is divide by 10 or times 1/10. So if we look at our answer choices, it says 70 times. We know this is wrong because place value is a base 10. It would either be times 1/10 or divide by 10. So 70 times is wrong. Then we have 100th. Because they only moved over one place value, it did not go 100th. So B is out. C says 1/10. Going to the right is multiplying by 1/10. So this is a good maybe answer. Let's look at D. It says 10 times. If it had gone from 700 to 7,000, that would have been 10 times. But because we started with the box digit is blank the value of the circle digit, we're actually going to the right, which makes it 1/10, not 10 times, which means C is our answer. So let's recap. When you are looking at a place value question, you must have the same digit in order to compare them. If you're moving to the left, you're multiplying times 10. If you're moving to the right, you're going to be dividing by 10 or multiplying times 1/10. Either operation will give you the same answer.